Okay. So we have omega over r over here, r naught, and this comes out to MRO omega. Or I'm sorry, MRO V. V. Right. Okay. So that's the initial momentum. Once it hits the target, right, it would just be the, again, the final moment of inertia times the final angular velocity. And that's where we're looking at. What is the angular velocity of the cylinder after this? And the bullet embeds into the cylinder. So let's figure that out. So really, the angular, the moment of inertia is two terms, one from the pulley and one from the mass itself. So we have the from the bullet itself. This is the bullet term plus 1/2 r naught, 1/2 large M r naught. That's the pulley term, and they're both multiplied by omega final. So now we're given the masses and the velocity and r naught. So we don't have any more. We don't have any more terms to solve for. We just calculate for the angular, the final angular velocity. And that's equal to this. Okay. And that will conclude these two chapters. Don't worry about the rest of the material. 11.7, 11.8, and 11.9. They're quite interesting, and this is a very, very, very rich topic. So if you're interested in it, please read it. And then this homework will be due. I'll give you these two homeworks. It'll be due next Monday and Tuesday, okay? Or Tuesday and Wednesday. I'll have them do Tuesday and Wednesday, okay? And then that's it. Take care, guys.